Good evening, everyone. Um, Thank you for being flexible with me, and thank you for completing the quiz before the deadline. You guys deserve a clap. And before we meet next time on Tuesday, my bad. Um, I just want to give you a quick reminder that this will be our last week of class. On Tuesday, we'll have the last discussion, which will be on scatter plots. Um, and on Thursday, we'll review the stuffs we'll have for the final exam. Remember, it's a comprehensive exam. That means the topics which we have covered from the beginning of the semester, everything will be included for the final exam. Okay, without wasting any more time, let me start today's discussion. If you remember, we did discuss 5 different types of crabs. Let me write the names real quick so that you can remember. I'll start with this. Obviously, we had bar diagrams, right? And then we had pie charts. Apologies for the handwriting because it's not the traditional Apple Pencil. Sorry about that. The third one is, well, it doesn't need to be in any order, so I can write one by one. The stem leaf plot, if you remember. The fourth one was histograms. And last but not the least, pictographs, right? Okay. Now, since we have already discussed this on Thursday, today we want to do some follow-up activities. By activity, I mean I'll ask questions and then obviously I'll try to answer those and convince you that why it works or why it doesn't work. Okay, let's start with this. Our first question could be, well, let me write it for you. Okay, the first question could be, if we have a categorical data, let's say categorical data set, then which type of graph out of the 5s we have just mentioned here, which graph out of these 5 will be a very good choice for us? I mean, if we have, let me try to rephrase it. If we have a categorical data set, which type of graphs can we choose to represent or to display the data set precisely, right? So we want to ask this question first, and then we want to find 2 different types of answers. Obviously, the first one would be which one suits the best or the better, which one suits better, and which one doesn't, or which graphs are not really suitable for this type of data set. We want to answer from both the point of view, from both observations. Okay, so we have categorical data set. Just try to remind yourself a real, a quick flashback, I would say. What type of data set can we say or can we visualize when we hear this word categorical data set? A type would be the hair color, right? That means it doesn't need to be associated with a numerical value. It doesn't need to be assigned with a numerical value, right? It could be anything. It could be a quality, and we can try to differentiate things using that. For example, as I said, hair color, eye color, right? The designations of the instructors here. Maybe we can say how many, or rather, yeah, that's still a numerical value. Maybe not a good option, but we can try and imagine different ways which can categorize these things and doesn't necessarily be associated with a numerical value. Okay, so let's, without wasting or without trying and generating an example, let's stick to a very well-known example, which is the hair color. Okay, so if we have a data set, let's say the hair color of the students of Math 1105. So I guess we can probably think of this, you know, one could be black. Obviously my hair color is black. One could be, let's say, brown. Or no, I think brown is not a good option. Maybe white. That means blonde hair color, right? Maybe you can do golden, right? And we can have different hair color. No, so if we have hair colors like this, or we could be, red, right? Often we see red, not really red, but kind of reddish. I guess we call it brunette, right? If I remember precisely. Anyway, we're not really doing anything with the different types of hair color, to be honest. We'd rather want to use this idea to explain our answer. So for example, let's say we have these 4 different hair colors. And if we have a data set like this, how can we, or rather, which type of graph can we use to display the data? So the first thing that comes into my mind, it could be a pie chart, right? We can clearly draw a pie chart, using different colors like this. And we could probably do things like this, saying that this yellow portion means black, this green portion means white. I think we should have one more. Let's try here. Sorry. Then we can say this color would be the golden, the amount of golden we have, right? And for red, let's use just red. This one would signify the red hair color. We can clearly use a pie chart for a categorical data set like this, right? We can also use a bar graph, for example, like this. Let's say, I can say this is red, this is black, depending on the number of students we have, right? Obviously, these also depends on the number of students we have. But I'm trying to say that we can actually draw graphs like this and say that this is black, this is white, golden, red. We can draw a bar graph like this for categorical data, right? We can clearly do that. We can also do, let's say, a pictograph, maybe. If we have a categorical data, we can probably do a pictograph depending on the shape we want to use. But can we do, for example, a stem leaf graph? Can we do that? And the answer is no, that might not be a good option. Why? Because if you remember, for stem leaf, we actually differentiate the values. For example, if we have values like this, just a quick reminder, 10, 11, let's say 17, 25, 28. If we have values like this, we actually separate the values in the tens and then the values other than the tens position, right? So we actually do something like this. We do 1, and then we have 0, 1, 7, we do 2, then 5 and 8. So if we have a categorical data, this doesn't look like an option for us, right? Same goes for the histograms, because on histograms, we do need ranges, you know, a range, let's say from 5 to 20. And within that range, we subdivide the range into some smaller ranges, let's say 5 to 10, then 10 to 15, then 15 to 20, something like that. So we need to have numerical values to actually display the data using stem leaf and the histograms. So the categorical data, I mean, for the categorical data, this too doesn't look like an option. Okay, next. Next, we want to ask, what if we have a discrete data set? What if we have this sort of data? Again, a quick reminder, a discrete data set would be a data set using complete, I should say, whole numbers. That means it doesn't have any decimals or fractions, right? It only contains the whole numbers, complete values, I might say, to rephrase or to reiterate it. Okay, for example, if I ask you how many students are there in each of the courses you have taken this semester, it cannot be 4.5, 7.25, or in something like that. It has to be whole numbers, right? Like 17, 23, 50, whole numbers like this. So if we have a data set like this, which type of graph would be a good option? Okay, let's see. So obviously, a bar graph would work, right? Because we are working with whole numbers. No worries with the bar graph. A pictograph would be a very good choice, right? Because we can draw a shape, assign a certain number to it and say that it's increasing. This is how it's increasing. Then obviously pie chart would also work, because as you can see, we'll be working with numbers. So no worries with that. But does STEM work, or will the STEM leaf work for a discrete data set? Okay, so a very good brainstorming work for you would be to imagine a situation where it doesn't work for discrete data set. So what if I say you have a discrete data set, but all the values look like this? Let's say 10, 11, 12, 15, 19, 17, like this. Well, or I might tighten the situation. Let's do even else. Let's do like this. Let's do 10, couple of 10s here and there. It does look like a 16 though, sorry about that. 11, 12, 12, 10, something like that. So STEM doesn't look like a very good option, because you can see if we start drawing this, or if we start working with this, it doesn't look very good. That's the end. So, you can obviously use this to display, but is this a good option? I don't think so. So what could be the reason behind it? Well, if your data are spread out enough to generate several items, then it's a very good option, right? For example, if we had something in the 20s, something in the 30s, if it's spread out, then it's a very good option. We can use that. How about histograms? Well, obviously, since we are working with data and whole numbers, histogram is pretty much a very good option. But again, it needs to be spread out. If it's not spread out, it may not be a very good option. It needs to be spread out. For example, for this data set, how do you draw a histogram? It doesn't look good. You start from 10, end at 12. Maybe you can have something at 11. It doesn't look good, right? 10, 11, 12. It doesn't look like a very good option either. But if it's spread out, then obviously it could be a very good option. Now, we can see for a discrete data set, depending on the type of data set we have, that means if it's spread out, if it's not too big, if it's not too big, by this I mean if we don't have a data set, for example, for 1,000 students, or I could say for 50 different types of data or information, 50 different types of data, then it might not be a good option for a pie chart, right? So other than that, all the options could be used. But if we have a bigger data set, pie chart won't be a good option. If we don't have a spread out data set, then STEM and histogram don't look like a good option, right? So generally, if it's a spread out data set, if it's not too big, not two different types, and not too many types of data, then we can use any out of these 5. But if it's not spread out, we should not, or maybe it's not a good option to use the histogram or the STEM. If it's a big one, then it's not a good option to use pie chart. Okay. All right. Next, you can probably imagine which one I'm talking about up next. It's definitely the continuous data, right? We already have categorical, and from the quantitative data, we know we have 2 different types. One is discrete, the other one is continuous. Okay, if we have a continuous data or data set, I should say, which one would be a good option? Well, a very good way to start would be which one is not a good option. Obviously, since we'll be working with continuous values, that means we'll have fractions, we'll have decimals, we'll have values, you know, everywhere, you know, like this. We probably have values like a 10.5, 11.3, something like this, right? We'll have values with decimals and fractions. We'll definitely have whole numbers or integers as well, but we'll have fractions and decimals. Okay, so since when we generate a pictograph, we generally assign a certain number for it. For example, a shape like this would mean 10 values. Then if we have 5 of these, we can signify then we have 15 total, right? This will actually imply that we have 50 of those, whatever that is. That means we generally work with whole numbers when we work with pictographs. So for continuous data set, pictographs doesn't look like an appropriate option. How about bar graphs? Again, for bar graphs, generally we have whole numbers because we have shapes like this. Obviously, we can work with decimals like a 12.5 or 15.5, something like that, if it's half, if it's quarter. But if we have, for example, 12.3, 11.7, you know, then it may not be a very good option. We can still use it, but it doesn't look like an appropriate option, right? Rather, if we have a pie chart, if we have a histogram, if we have, you know, a spread out data set, we can use a stem leaf as well. Well, you might be wondering how could you use the stem leaf plot? If we can just terminate the decimals conveniently, then obviously stem plot could be used. But only if we can conveniently terminate the stem plot. But a pie chart or a histogram spatially could be easily used for this, because, for example, for a histogram, that's the good thing about histogram. We generally use ranges like this. So we have, let's say, 5, 10, then 15, 20, 25, 30, etc. So whatever falls in between this, if let's say that's 5 and 10, even if we have a value which is 5.77, we can still draw that in this area. We can still count that in this area, right? So a very good option would be histograms. This is 15. So if we have 11.3, we can definitely use that in this area. So histogram would be a very good option. We can also use pie charts depending on the categories we have. We can calculate the percentage. We can find the portion of that portion of the area we'll have to draw in that pie chart. We can calculate the angle depending, or rather calculating the percentage we have, and then you can draw pie charts. But pictographs doesn't look like a good option. Bar graphs is not a good option either, right? Okay. Next question we want to ask ourselves is, how to compare a bar graph and a histogram, because it looks pretty similar. Often it can confuse you. Hey, especially when you start with, if you eyeball, you can think, hey, what's the differences between these two? Back in my days, I used to get confused when I just started doing this. Then I actually tried to think how to differentiate this, and that's what we want to do now. We want to compare. That means first, obviously, we want to, sorry. First thing we want to do is to find the similarities between a bar graph and a histogram. And then we'll be finding the differences between these two, right? Okay, so the similarities between bar graphs and histograms would be, obviously you can clearly imagine both these graphs actually show the frequencies, right? Whatever categories we have, whatever different types we have for the data set, we actually use, or rather we actually show the frequency of a certain thing. And obviously we use bars for both of these. Even for histograms, I should have finished it before, we actually used bars like this, right? And even for bar graphs, we actually use bars like this. So that's another similarity. And again, that's why we often get confused by just eyeballing these two perhaps simultaneously, right? Because both these obviously giving us frequencies, it uses bars, it looks pretty similar. And obviously, both could be used for discrete data set. For discrete data set, both work pretty much fine. Okay. Now, what are the differences now? Let's talk about the differences of bar graphs and histograms. Okay, so for the bar graph, we could say it's more suitable for a categorical data, for a discrete data, right? Because for a bar graph, you can see we actually have spaces between each bars. Here we have space, 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 right? So it works pretty good for discrete data. It works pretty good for categorical data. I think it's one of the best fit for categorical data. Whereas histograms are actually better for continuous data. You can see, if we have a continuous data, histogram is probably the best option. We have some more graphs to check, but histogram is clearly one of those you can straight away use when you have a continuous data. And obviously, since it's more suitable for continuous data, you can see there is no space between two bars. Can you see that? It's actually connected. It's generally connected. I have seen some exceptions, but I guess exceptions are not examples. We can actually sort of neglect those. Generally, it's without spaces. Okay, what's next? Okay, we want to ask this question next, which is, if we have a discrete set of values, I mean discrete values, a set of discrete numbers, what type of numbers work well for a stem and leaf plot? Okay, let me write it for you real quick. I should right here, similarities between bar graphs and histograms, and that's the difference. Okay, and for this one, we're going to ask ourselves what types of numbers work well for a stem, for a stem leaf plot. Okay, I guess we have already asked, or rather answered this question, probably not thinking this question precisely. We have already answered this question. Can you guess? Pause this video, try to imagine. Okay. So if we have a stem plot, it works really well when it's spread out. If the data set, if your data set is spread out, as I said, this is the example I'm talking about. If your data set is spread out, is well spread out, then it's really good. You know, it works very well for a stem and leaf plot. If it's not spread out enough, then it might not be a good option, right? Okay. Next question would be, you know, again, we have answered this. What types of numbers do not work well with stem and leaf plot? It is what doesn't work, right, for a stem leaf plot. Again, it's basically the same answer, just in the opposite direction, that it doesn't really work well when the data is not spread out enough. Or we might say, let's say it does have, you know, so many values for a single stem, like this one. It had only values from 10 from 10 to 20. I mean, the only stem value was 1. So it doesn't work well for a situation like this. Okay. And now, finally, and thankfully, the last question we want to ask ourselves is this. So I want to add this photo for that. Here you go. Okay. And this is the question we want to ask ourselves. So we have 5 different types of graphs. And for each of these, we want to check which values or which of the following 5, which is this 5 precisely. Let me, oops. That is, which of these 5 can be derived from these 5 graphs? Which can be derived from which one, right? Let's check one by one. And we will try to answer this using, or rather saying that this could be calculated from the graph, or this is completely not provided. Okay, all right. First of all, the actual data values. So for the bar diagram, the actual data values are provided. Obviously, when you see a bar graph, we can see the different types, we can see the frequency, we know the actual values. Pictograph, definitely, we know if we have assigned a certain value for a shape, we can see how many of those are there, we can see the values, so it's given. Pie chart, well, I would say it's often given, but not always. Since it works with percentage, we may not be able to derive the actual data values from a pie chart. We may not be able to do that. Or often, we may not need actual data values to draw a pie chart, just the reversed order, by the way. Stem leaf, since we deal with numbers, we separate the values from the 10th position and the other values. Obviously, the actual values have to be given. Histogram, well, in the graph, I mean, when you see a histogram, you can probably never derive actual data values from that. For example, in the range of 10 to 20, the frequency, let's say, is 15 or 12 or 10. But can you see the actual values from there? No, you can't really derive, or it's not exactly given in a histogram. If you just eyeball a histogram, you cannot see the actual values. Okay, frequency counts, again, in a bar graph, definitely frequency is given. We can see how many of those are there. For pictographs, definitely you can count, right? For pie chart, again, as I said, since we work with percentage on occasions, we may not be able to compute it. Often we could, but sometimes we can't. We can compute it, compute the numbers, compute the frequencies, if we know the total number of people, because we work with percentage. So we can probably, if we know the total number of people, we can work, or rather use those percentages to find how many of those falls into each of those categories, right? Okay, stem and leaf, frequency, we can actually count, right? Because we can separate the values from the tenths and the other positions. So you can actually calculate. So I would say we could calculate the frequency, okay? And for histograms, obviously it works with frequencies, but not for precise values, only for ranges. For example, we can see how many falls into the range from 5 to 10, but we don't know exact frequencies of how many 11s do we have, or sorry, if we have 5 to 10 range, how many 7s do we have? We can't really count that, but we can definitely count how many numbers do we have in between 5 to 10, for example. So if for a given range, we can, for a given range, you can definitely count the frequency, but not for a precise value. Okay, percentages, obviously, you can clearly imagine the percentage is definitely given in the pie chart, because we actually draw using a percentage. We draw pie charts using percentages, so it's definitely given. From a bar graph, we can calculate. It depends on how it's represented, we can definitely calculate the percentage if every categories have a certain frequency. We don't have any overlaps in between. I guess we can definitely calculate. Pictographs, again, we can calculate because we work with numbers. We can calculate the percentage. Stem leaf, we can calculate because we can see the numbers falls into each category. And for histograms, again, the same scenario. We can calculate the percentage for a range, for a certain range, 5 to 10, 10 to 15, not for a certain value. Okay, we can calculate it for a certain range. Okay, now we want to ask the most important question, which is, can we see or can we derive the mean, median, or mode? Well, if we have a categorical data, if we have a discrete data, for a bar graph, we can calculate all the three. If we have a discrete data, we can calculate the mean, mode, median for a bar graph. So a big yes, if it's a discrete data set, we can compute mean, median, mode, all the three from a bar graph, because you can see the frequencies, right? It's discrete, so we can see the numbers. We can clearly calculate the mean, mode, median. Well, mode can be eyeballed. It's pretty straightforward, and mean and median would not be that difficult to calculate. It would be straightforward. Okay, if it's a categorical data, only mode can be calculated. So it's just this. For a categorical data, only mode can be calculated, because you know mode is nothing but the number of occurrences for a certain value, right? The highest number, obviously. So you can see which bar is the largest, and that would give us the mode. We can definitely calculate the mode if it's categorical. Same goes for the pictograph. If it's a categorical data, we can definitely calculate the mode, because you can see which portion has a bigger picture in our bigger line or larger number of shapes, however you have assigned the shapes to, or however you have defined the shapes. So you can actually calculate the mode. And once again, if we have a discrete data set, we can calculate all the three, because it's whole numbers. It's pretty straightforward to calculate the mean and median if we know all the numbers, because it's discrete. It's whole numbers. It's pretty straightforward. But for a histogram, we cannot do anything. The reason I am going straight to histograms, skipping the other two, because you can see in a histogram, you can probably see a larger bar, a larger building. You might say those are buildings. Those look like tall buildings in New York City or Los Angeles, something like that. Not in Laramie though. But you cannot really find a mode from that, because that's for a certain range, and you don't know which value has more appearances, which value has appeared more times in that range. So you cannot calculate mode, and for the same reason, it's impossible to calculate mean and median from that as well. Okay, stem and leaf, we can calculate. So I'd say a green, because the reason I'm saying that we can, because we can see the numbers, so we can rearrange this and do the analogous way to calculate all the three. How about pie chart? Well, for pie chart, often the actual values are not given, right? We know that, we have seen this. If the actual values are not given, then we can't really calculate this. But if it's a categorical data or a discrete data, since we see the percentage, we can definitely calculate the mode, because you can see which area is bigger, and that area would be our mode. That particular category would be the mode, right? So you can calculate the mode, especially if it's categorical, or even if it's discrete, you can still tell what could be the mode. Okay, last, spread of the data. Well, for a bar graph, obviously, since it works really good with categories and discrete, obviously you can see how spread out the data set is. Same goes for the pictographs. We can see how spread out the data set is. For histograms, definitely we can see how spread out it is, because it gives us it works really good with ranges. So we can see the range, and this actually, and obviously you can see the frequencies there. So you can see how spread out it is. It's a very good observation from histogram as well. From stem leaf, again, we can see by just eyeballing the stems. We probably won't need to see the leaves. The leaves will be providing us with more precise idea or more precise information, but we can probably eyeball the stems and see how spread out the data set is. And from the pie chart, we can see the percentage. So we get a good idea how spread out it is, but we cannot really, or we may not get a complete idea of the spread outness from a pie chart. Okay, so again, you don't need to memorize this. You can probably try and imagine this when you are thrown into a situation like this. When I ask you a question, when I throw a question to you, when I ask this, you can probably try to generate a situation like this and find answers for it. So if you have any questions or concerns like this, or from this, I would say, from this entire discussion, just shoot me an email and I'll try to reconvince you. If I've done a mistake somewhere, which I could, I'll definitely try to resolve it. But if I haven't, definitely I'll try to reconvince you. So shoot me an email once you are done watching this video, and just ask yourself what could be the reason behind saying yes, what could be the reasons saying no, what could be the explanations between these, for using these graphs for 3 different types of data set we have, the similarities and the differences between histograms and bar graphs, which look pretty similar often. For stem plots, why it doesn't work doesn't work well for a less spread out data. You can ask questions like this. You can probably try and go over some worked out examples from our book or from some other resources. And if you have any questions, as I said, just shoot me an email or we can discuss it on Tuesday. So thank you for having patience, and thank you for being really flexible with me. I'll see you on Tuesday for the last week of class. Take care.